Hey guys, I wanted to record here our first troubleshooting video with the mole to go through some tips and tricks on how to read and convert some of these problems. So, what is a mole? Well, you guys know a mole is a grouping of particles, right? So we can convert moles to particles, whatever that means, using Avogadro's number, 6.02 times 10 to the 23rd. The problems never say particles though. So really, what do we do there? Well, we can convert from that is actually, we could say molecules. That's a type of particle. Or we could say atoms. That's a type of particle, but that's the scenario where we would use Avogadro's number. So Avogadro's number is only useful in this area if you're talking about individual things and trying to group them together, or you have a group of things and you're trying to figure out how many individual things there are. So when you read these problems, your answers need to make sense accordingly. If we're talking about moles, how many moles do you have, and we're trying to go this way, that should be a small, reasonable number, just a few moles or a few tenths of a mole. But if we actually need to calculate as our final answer how many atoms or molecules, well, that should be a very large number because a mole has a huge number of atoms and molecules. Okay, so one of the other things though that gets really tricky is we can actually convert between atoms and molecules as well, and that's just a numerical conversion between like how many there are. So let me give you an example of that one. If we had zinc nitrate, okay, and we wanted to say how many, if we had 1 mole of zinc nitrate, sorry, this should be a 2, zinc has a +2 charge. If we had 1 mole of zinc nitrate, how many molecules of zinc nitrate would we have? Well, that would be equivalent to 6.02 times 10 to the 23rd molecules. And it's really important to write molecules down. And the formula is zinc nitrate. Okay, but the other thing we can do is we can actually say, okay, that's zinc nitrate, ZnNO32. How many actual atoms of oxygen are in there? And we can break it down further because this one molecule has a lot of atoms in it. So there are inherent conversions in here that we can think about it a little bit smaller. We could convert and get another conversion here. I'm not setting up the math, just thinking that 1 molecule of zinc nitrate actually has 6 oxygen atoms, 3 in each nitrate, has 6 atoms of oxygen. So there's a way that we can take a conversion factor right out of the molecule. It's a 1:6 ratio. 1 molecule has 6 oxygens. And we can use Avogadro's number to go from moles to molecules, but then we can even dive into it and say, okay, how many individual oxygens are there? So that's a useful skill. Sometimes we need to look inside the molecules to see how many things there are to convert. So that's one troubleshooting tip that comes up a lot. Now, of course, I didn't set up any of that dimensional analysis, but what I did is I gave us, we have a mole. We can now convert to atoms or molecules using Avogadro's number, or we can actually go back and forth between those as well. The other thing we can do is grams. And that's going to be on the periodic table. So anytime you have a mass, we have to use the periodic table. Anytime you're counting an actual substance to individual pieces, that's when we're going to use 6.02 times 10 to the 23rd particles. Okay, so is 1 mole. And as long as your units cancel out, if you're writing down your units, you should do a really good job canceling these guys out. Figure out where you need to start with, put it over 1, and then just kind of play this, okay, what can I do next? How can I convert it with the next step? And you can kind of go between those guys. Good luck.